Clever. Space-time, though, as we understand it, shown here in a two-dimensional construction, is distorted by mass, the effect of mass on space-time. Interestingly, it will also cause light to bend as it travels. Those of you that saw the little clip on the Cruise Director's channel, I would teach you how you could travel through time. And I wasn't kidding, you actually can travel through time. Yes, it's not simple, and yes, you need special equipment, but I'll show you how you can do it. Alright, the easiest way, of course, to experience time travel is to go out onto the deck and look up at the sky. Yeah, that's a cop-out, right? Because every one of those stars is so far away, what you're looking at is how they were hundreds or thousands or even millions of years ago, because it's taken so long for the light to reach us. Remember, I said our nearest neighbor, 4.2 light years away. We're seeing what it was like 4.2 years ago. If you look into the center of the galaxy, which is about 100,000, it's about 50,000 light years to the center of the galaxy, then that's 50,000 years ago. That's what it's like. So if you look into the sky and you look at some distant object, it may not actually be there now, because it may have gone through its life and death cycle, and yet we don't have that information yet. So yes, you can experience the effect of time travel. And there's the sun, 8 minutes. If the sun goes out, you won't know for 8 minutes. Reassuring, isn't it? So here we are, there's our sun. That's 6,000 light years in diameter. So that's what you're looking at. This is our Milky Way. As we look at Andromeda, which is 2 billion light years away, you're looking 2 million years into the past. Reassuring thought, everybody. In about 3.84 billion years from now, Andromeda and the Milky Way are going to collide. Worried? No? Understandable. It should be really interesting, because around about the same time, the sun goes red giant and we'll all be incinerated. If we look into the Virgo cluster, which is the cluster we're in, we're looking back 60 million years, and if you go back to the very beginning, well, that's 12.6 billion light years. We're actually able to see now, with today's technology, back to just a few 100 million years after the Big Bang, so I'm talking about 13.4 billion years. We are detecting radiation that's been traveling for 13 billion years. This is a paper written by 2 Canadian authors, as a matter of fact, discussing time travel going backwards. Now, one of the things that you need to be able to do this, if you can in fact convert the field equations that have been developed into reality, is you have to harness exotic matter. That's a problem. Exotic matter does exist, but it's not easily handled. The other problem with this is you would be going back into alternate universes. So even if you did manage to handle the exotic matter and go back, it would be a very different place. In fact, it could be a universe of antimatter. And for those of you that don't know, matter and antimatter don't like each other, they annihilate, and you will become a flash of radiation as you exploded. So not so good, and of course it would be a one-way trip, because you would be going into an alternate universe, not this one. Not going to happen, really. However, there is a way that you can do it, and this is through the predictions from relativity. This equation up here, which I won't go through, but just to refer to, tells you what happens to time as you start going faster and faster and faster. As you start to approach the speed of light, time for you travels at a different rate than the observer that you left behind. It slows down for you. And I'll give you an example in a minute. So the TARDIS, of course, is immune to that because it doesn't travel that way. So if you travelled close to the speed of light, here's an example. These two are brothers, if you like, or twins. He's going to take off and he's going to go for a long flight at the speed of light. He is going to come back pretty much unchanged in age, but his brother will have aged. this too is a one-way trip, but you are traveling into the future. Quite possible if we could build something that traveled at the speed of light. But feasible. Have a look at this. This graph is showing you if we could build something that would accelerate constantly at 1g, which is the force of gravity that we experience here on the planet, so it would feel very comfortable in that spaceship. If you could constantly accelerate at 1g, we would end up here in the middle of the, yes, that's the edge of the visible universe. And that round trip is 100 years. Here is Rigel, the star, about 25 years. There's the center of the Milky Way. We could do that round trip about 40 years. But this is the Earth years on this scale here. And we are about 1 million years here if we went into the center of the Milky Way. We've only aged about 40 years going there and back under these circumstances, but 1 million years has elapsed on planet Earth. You could do it if you could build this ship. Now, there are other problems, of course. Fuel. Where are you going to get the fuel from? How are you going to store that amount of fuel? So you obviously need some other kind of drive, but nonetheless, the physics says that you can actually do this. The other problem too is as you start to approach the speed of light, drag becomes an issue on your spaceship, and I needn't tell you what's going to happen if you actually collide with something at these speeds. Space is not completely empty. Could be a problem. Remember Apollo 13? That little collision, and they weren't traveling very fast at all. But the physics says you can travel into the future. One-way trip. Time moves at different rates. As you're moving faster and faster, time slows down. As you go into a gravity well, that is, the more gravity you experience, time runs slower. So another thing is if you could find a high gravity area, such as a black hole, time would go very slow. Problem there is the gravity would tear you apart. But nonetheless, you could do it. Time runs at different rates depending on how fast you go or where you are in the universe. This is how you can do it very simply. Go live in the basement, and you will add 90 billionths of a second to your 79-year lifespan. You will outlive your relatives who are living on the top floor by 90 billionth of a second. Can do it. Probably not worth it, right? In the basement. This was discovered in 1960, how special relativity and general relativity affect clocks, the rate of clocks at different heights in the gravity well. So up here in the very, very tall building, use your imagination, it's got to be really tall, not just a skyscraper. They run faster, and down near the surface of the Earth they run slower, so the clocks run at different rates. This has an effect on everyday life. How many of you use GPSs? Oh, come on, you all do. All your hands should be up. Yes, that's right. Don't be shy. If the time correction wasn't applied to the clocks in the satellites for the GPS position, your position on your map would change by 12 kilometers per day. It's less than 10 miles, about 8 miles per day. I didn't put the conversion on there, but that's how much. It's very significant for a very small change in the clock rate, because it's 39th millionth of a second per day. That's the difference in the rate of the clock in the GPS satellite and on the surface of the Earth. But it translates into that very significant distance. And that's from Einstein's predictions. Affects you every day. Robots. Let's have a look at robots. We have robots in Doctor Who. That's Lost in Space. That's Hitchhiker's Guide to the Galaxy. Where's that one from? Good. That's from Doctor Who. It's one of the death robots. K9, one of my favourite robots in Doctor Who, obviously, dogs, K9. It's been through several iterations. You're going from Mark 1, which is very primitive, up to Mark 4, and all basically looking like this and having different abilities. Delightful little thing. Anybody ever been to a Comic-Con conference? Have you seen a K9 there? I did. Yes, you did. You can see Daleks there too, by the way, at Comic-Con. Robots today, well, we do use them in all places. We've got drones, of course. Well, that is a little bit under human guidance, but there are drones. We have medical procedures that can be done with robots. We have, of course, prosthetics and exoskeletons, artificial assistants, airport assistants. This is in Incheon Airport. These little robots will take you from one place to another and give you information. And then, of course, we are maybe entering the age of driverless cars, maybe not, based on the problems they've had in the past. This is Asimo, developed by Honda. They've been working on this for quite some time, 1986, and yours for a mere 2.5 million. But there are others which you can buy too. I haven't highlighted them all. I do want to show you, though, what is being developed in second by Boston Dynamics. This is Kismet. Kismet has rudimentary social skills, so a conversational robot. You can see this one at MIT. It's still there. And here is the Boston Dynamics Atlas robot. And have a look at what it can do. I definitely want one of these.
Aww.
Now it's all metal. Think how heavy that is to get up. Can you do that? I can't. And where's it going to end? Let's hope not. The aliens in Doctor Who are varied. I'll present some of them here. The Cybermen.
We will add your biological and ethnological distinctiveness to our own. Your culture will adapt to service us. Resistance is futile.
I love that line. Resistance is futile. Similarities between the Cybermen and the Borg. They both assimilate populations. They both travel through time. That's transwarp, same thing. These, though, function as individuals. They are part of the collective. They need a hierarchy, but they all operate as a community. Today, what do we have? Well, we have additions that we can put into our body to keep us working right. We have heart and brain pacemakers. We have an artificial heart that has been successful for a long time. We have artificial joints. I'm sure some of you have even got some. And the way my knees are heading, I will be too at some point in the future. The cochlear implant to help people hear, synthetic trachea for some people, prosthetics, as you see here, the running, and of course research just keeps going in keeping us healthy and alive.
You will remain silent. The Daleks are the superior being. We do not require assistance. It was but one
Who didn't have nightmares when they were a kid on the first few series about being exterminated? I know I did. Anyway, they certainly evolved through the history of Doctor Who. And they're not robots. They are living creatures inside of these mechanical bodies. This is roughly what they're supposed to look like. And they are just evil creatures. Evil indeed. They want to take over and destroy everything, exterminate, their favorite phrase. Well, what do we have today in that kind of thing? We do have life support shown here. We have electric wheelchairs. Thank goodness they don't have ray guns on them, but of course in this speciality wheelchair here, some of them have miniguns. I guess he's an avid hunter, doesn't like to miss. Some of the planets the Doctor Who has in the program. In our own galaxy, we have about 100 billion exoplanets, we estimate, in our own galaxy. In the universe, it's just a huge number. It's not even worth talking about. It's so big. Do these support life? Well, we've yet to find out. We are still searching. These are some of the techniques that we are using now to discover exoplanets. I won't go through all of these because that's a talk entirely in its own to discuss all of these techniques. So things are actually made out of diamond on midnight. Well, 55 Cancer E, which is in the constellation of Cancer, about 8 times the mass of our own Earth with an 18-hour orbit going around its sun, has a density that's 5.9 grams per cubic centimetre. That corresponds to being predominantly carbon on this planet. So it's speculated there could be lots of diamond on that planet, like midnight. This is Gallifrey. Gallifrey is located a long way away from its star. There's the host star. It's out here. That's the name of the planet. Astronomers give strange names to things. There was a petition of about 140,000 people that asked for that planet to be named Gallifrey from the International Astronomy Organization, but they turned it down. So there is in fact no planet named Gallifrey, unfortunately. And for those of you that can read the script for Doctor Who, that says Gallifrey in that script, Gallifreyan. This is Gliese 1241b. Could this be Androzini Minor, which is a desert planet? It's shown here in an artist's impression. It's quite close to its host star. It orbits Sirius, a star that you can see in the sky, the brightest star in the sky. And if we have chance to do some stargazing on this voyage, maybe I can show you where Sirius actually is. So being so close to the host star, of course, everything will be burnt off. This is Mondas. Mondas is the home of the Cybermen. It's a rogue planet. What does a rogue planet mean? A rogue planet is one that is not attached to a star. It's floating freely through space. Is there such a thing as freely floating planets? The answer is yes. We have found some. They are all Jupiter-sized. And of course, as they travel through deep space, the internal heat dissipates and eventually they become very cold places because space is cold. This is the Ood sphere. This is an artist's impression of what the Ood sphere looks like. It's one of the moons of a ring planet. It's in the same system as the Scent sphere, another planet, and it is located in the Horsehead Nebula, which indeed exists, and it's named the Horsehead Nebula because it looks like a horse's head. Then there's the Scent sphere, and in the description of the Ood sphere and the Scent sphere, we find out that there is no nighttime because it is in a circumbinary system. A circumbinary system is 2 stars that are going around each other. There are lots of circumbinary systems in the galaxy. This is quite a common occurrence now. Whether the radiation from the stars rotating around would be suitable for life on a planet is another matter. The planet could get very hot or very cold depending where it is in its orbit around these two. So no natural nighttime if you're in that system. This is San Helios. San Helios has 3 suns. There's one there, one there, one there. 2 are blue, 1 is red, so 2 are very hot, and the red star The red sun is one that is very long-lived and is cooler than the two blue, which are much shorter-lived than the red ones. It's supposed to be on the other side of the universe from Earth, and in fact, yes, we have found some of these triple star systems. 7 have been found so far, and one of them is Gliese 667. So, yes, we know they exist. What's the best name? I figured I'd make a fool of myself if I did this on stage. This is the best name. So, how do we pronounce that?
Raxicoricophalopatorius.
Thank you. And on this planet lives this strange beastie. And how do we pronounce that?
Paradelskalium rexius beast.
Thank you. Demon's Run. Demon's Run is an asteroid that was used as a military base in one of the episodes of Doctor Who. And there's a schematic of it. Can we do anything with these sort of things floating in space? Well, yes, indeed we can. Do you remember the Rosetta mission? This was a 10-year mission where we sent up the Rosetta orbiter and we put the Philae lander down on that comet. Unfortunately, things went wrong. It bounced, it lost power, and we were only able to get some limited information from the Philae lander. What about equipment that we see in Doctor Who? Well, of course, there is the sonic screwdriver.
It's breaking an entry.
What about a break? Sonicking an entry. 10. This is the sound none of you wanted to hear. 9. You're fine. 8. 7.
Well,
I don't know. Haven't seen what close. 6. Move! 5. 4. Hello, fishy. What do you eat? 3. Hello. 2. Use of a sonic screwdriver.
See, that ship up there is scanning this area for non-terrestrial technology. And nothing says non-terrestrial like a sonic screwdriver.
So these are some of the things the sonic screwdriver can do. You saw some of those in that little video. I've got 2 sonic screwdrivers at home. Unfortunately, they seem to be broken because they don't do any of that. Oh well. But sound, in fact, can be used in a variety of ways. You're familiar with ultrasound. Who hasn't had an ultrasound? I'm not asking you to show hands, but who hasn't had one? Pretty much everyone, I think, in this room has probably had an ultrasound at some point. You can use sound to break glasses. You can actually use sound for levitation. You can use it as a weapon. This is the sound cannon on the Queen Mary 2, which is deployed when and if it has to repel boarders. And there is an unfortunate side effect of sound that at 18 hertz, 18 cycles per second, it resonates with the human eye and can cause vision problems. So sound has a variety of uses. Here's an example of breaking a glass with sound. You see it resonates, gets to the point where it just can't support the resonance anymore, and it breaks. Here's another view from the top. You see it again being broken by the resonance of the sound waves vibrating the structure of the glass. I think you get the idea. And then there is this, which is levitation using sound. This is not magnetism. These objects are being placed in a sound field, which is vertical. And in fact, once you've got the objects in the sound field, you can move them around by varying the frequency in the sound field. This is the frequency of the sound field being changed, and the spacing can be moved. As yet, very experimental, but it is a way of remotely handling objects using sound. liquid drops being placed in the sound field in that example. We are indeed so inventive. Those are the liquid drops in the sound field that you saw being placed just earlier. And that brings me to the end of looking at some of the science that we have in Doctor Who. As always, because we are so congested with different talks and different activities on the ship, I can't take questions here. If there are any questions about Doctor Who, or indeed anything else for that matter, or dogs, it will be outside the theatre immediately following my breakdown here. So, thank you very much. I will just add that the last sea day, the next sea day, because there's only 3 sea days, will be the time we do the dog behaviour Q&A workshop, where the expert sitting down there will be up on stage instead of me, dealing with any behavioural issue that you have with your dog, your parents' dog, your children's dog, your neighbour's dog, or any dog whatsoever. And if it's not medical, if you do what she says, it will be solved.